Welcome back. I particularly like this example or the reaction that I've written on the screen because every time I have tested this on a test or a quiz or even on a homework, and say if the question had is if a reaction is possible, write the products, and if there is no reaction possible, write no reaction. At least 50% of the students or less had written no reaction. That's because I said double bonds must be alternate, right? So they look at both the diene and the dienophile, right? And they say, well, there's a lot of empty spots here, so I cannot move my bond. So I'm going to say this is no reaction, okay? That's not really the case, all right? Let's redraw this molecule again, okay? Now, you don't need to move every bond, but the bonds that you move, where you start, you must finish there. And if that's not the case, then yes, you do have a problem and there's no reaction. But in this case, there is a reaction. That's because if you write it this way, you will not have that problem. It's as if that people want to continue, keep going, you know, and that doesn't have to be the case, all right? So I'll show you how this actual will work. Now, yes, I cannot, if I start here, I cannot move because there must have been a bond here, okay? Or they move this one out. They just make things, I guess technically you can do that too. Like you can move this out, but we haven't learned resonance yet. And I don't think you have to know resonance to learn Diels-Alder. Okay, you can learn it without it. So let me start with this. So I am going to connect this as a bond between this carbon and this carbon, okay? This bond merely acts as a messenger, like I explained in the previous one. This bond comes over here, right? And this bond connects this carbon with this carbon. It's what you connect. You cannot just randomly connect bonds anywhere as you wish, okay? So that means let's go ahead and draw our molecule black and blue, okay? Just think of it this way for now. If you cannot move the bond and then move something else immediately, that means that is not an option for you, okay? Now keep in mind, draw everything exactly the way you had it when you constructed your mechanism, okay? Now let's go get our pinks, okay? Basically, if you want to connect, you see, this is where I started, that's kind of where I ended. And if that is not possible, that means you may have to recheck your work, or if you've rechecked it multiple times and if that is not possible, that means most likely there is no reaction. But you've got to be able to do this before you can make the decision. You cannot just look at a molecule and go, there's no reaction, okay? So this bond is used as a bridge to connect this carbon and this carbon. So I'm going to rewrite the two carbons and write the bond, okay? This bond has come here, so let's put it there. This bond, okay, if I actually would, basically this is where my other bond was, right? I guess I should have tilted it a little bit this way. Let me do this actually. Okay. Forget about this bond. Okay. Right? Because visually it might appear cloudy. So this is where that bond was. So that means what have I done? Okay. This bond is now used to connect, right? So that means we are connecting this with this. Oops. Okay. I have seen students prematurely connect this, but you cannot do that, right? Because this is what the bond that you're ending here, so you're starting here. You cannot connect this, you cannot move the bond here and also connect this carbon and this carbon. It's only this bond right here is used to connect this, right? So the bond that attaches cannot go here. Okay, it has to go here. And that's a mistake I have seen students say if they've gone that far. Okay. So just don't visually look at a molecule and start making decisions that it's not going to work or will work. You just have to work this out like I did. And if you want to use different colors, that's fine. If you cannot end where you started, okay, this is where you start. If you cannot end here, then there is a problem. That means you're not able to recycle the bonds. And what I have also seen students do is they start here. For some reason, they start here and they can't go anywhere because there's no double bond here. They say no reaction. That is incorrect. There is a reaction possible. You just have to maneuver this structure to this form. Now you can use this bond to work your mechanism. So try all possible combinations before you conclude that there is no reaction. And the reason I chose this particular one was I had actually given this exact same compound, these two compounds on a test, and at least 40% of the class, even though I gave the different structures, that means, to create that particular question, it takes time. So students don't think that way. They think, well, because I moved that bond on the far left and there's nothing to move immediately to it, so there is no reaction. So they went for no reaction as was one of the answer choices, so they went for that. But if they had taken the time to flip the molecule and then start moving the bonds around, then they see clearly there is a reaction that is possible. So, well, they didn't see that, obviously. So that's pretty much all I want to say for Diels-Alder reaction. I think I've said what are the key details of it. I think we will just have to practice with more examples. All right, so stay tuned.